Hi students, this is another problem taken from the book Irodov. Question number 4.28. It's a problem based on simple harmonic motion, and you also need to know about how to find torque and how to use Newton's laws. Okay, so it's a beautiful problem again. So here there is a plank, and there are two drums which are rotating. This one is rotating in the clockwise sense, and this is rotating in the anti-clockwise sense. Okay, and right now this plank is in equilibrium. Okay, then the question says if it is slightly displaced and then it is released, what would be the period of oscillation? So we have to find the time period of oscillation. So again the trick is same. Let us first ask why this is in equilibrium. So if the mass of the plank is m, then there will be a force mg here. There will be a normal force here. Let us say it is n1, and here there will be a normal force n2. Right now these two may be same, may not be same. Okay, so depending on what portion is outside, inside. So let us assume it is n1 n2. Now this drum is rotating. So if this is the plank, the drum is rotating this way here, this way towards my right. Okay, so this will feel a friction towards the left. Reaction of that friction will act on the plank towards the right. So the plank will feel a friction force towards the right. Let us call this F1. And this drum is rotating this way. So the plank is trying to slide this way. So if plank is trying to slide this way, plank will feel friction this way, right? It's like if you slide on the ground right, your foot will feel friction left side. So here the plank is not trying to move. It is this drum which is going this rotating this way. So at the point of contact, the drum is trying to go towards the left. So plank will feel friction towards right. Reaction of that friction will act on the plank towards the left. So right now, see what is happening is this F1 and this F2 are equal. This N1 plus N2 is balancing the mg force. So that is how they are in equilibrium. Now when it is displaced slightly towards the left, so this distance is given as L. Okay, so the given quantities are coefficient of friction between the plank and the drum and the distance between the center of the drums. So given quantities are mu and L. So your answer should come only in terms of this. Now, when it is slightly given a displacement x, let us say, so how will the diagram look? So drum is here itself. This drum is also here itself. But the center C which was here, now it is shifted here by x, right? And we get x. Okay. So the plank is now shifted in a way somewhere like this. Okay. Fine. So the center has shifted here. So there is a feeling that this normal force will be more now because more this normal force has to be more because more portion it has to balance, right? So now there is pakka that this two cannot be same. So n2 and 1, and this distance will be what from center. So this was L by 2, right? This was L by 2. So it has been shifted x distance, which will be L by 2 plus x. This will be how much? This was L by 2. It has come nearer by x. So this will be L by 2 minus x. Okay. So let us now understand. See, vertically there is no motion. So vertically N1 plus N2 should still balance Mg. And here friction is towards my left F1. Here friction is towards my right F2. Now try to understand this important point. Initially F1 and F2 were equal because it was in equilibrium. The moment you shift it towards the right, and the displacement is towards the right, N2 will become more than N1, right? Because more mass of the plank is towards the right side, so this normal force has to be more, right? So if I give you a plank and I put my hand here, then you have to support more weight. So the force here has to be more than here. So this N2 is more. So the friction here Since kinetic friction, we can write F2 as mu into normal force, so N2, and F1 as mu into N1. So F2 will become more than F1. So there will be a net force this side. So F2 minus F1 is the net force this side, which will cause an acceleration this side. So that will be equal to your restoring force. So let us try to first find restoring force, right? So the force which tries to bring it back is F2 minus F1, right? Okay. Now what is F2? Mu N2, this is, so mu will be common, N2 minus N1. So this is the restoring force which brings it back. Okay. So mu has come at least in the picture. L has not come. L was given. So answer should come in terms of mu and L. L has not till now come. So now you also realize that for a system to be in equilibrium, you know that net force should be zero, net torque also should be zero. I know this plank is not an equilibrium, mind you, okay? Vertically it is an equilibrium. So net force vertically is zero. It is like it is going to perform SHM this way, the moment you give it a slight displacement. However, this plank has no tendency to rotate this way or that way, right? So the net torque must be zero. So net torque must be zero. Which point shall we choose? We can choose the center of mass as the point about which we measure the torque. So about center of mass. You can choose any point C. Okay. So about C, mg is passing through C itself. So mg will not result in any torque. N1 will create a torque this way, right? So this is R perpendicular, this is N1. So the torque due to N1 will be R perpendicular is L by 2x into N. This will create a torque this way. What about this N2? N2 will try to create a torque this way. So minus L by 2 minus x is the R perpendicular for this force for about center of mass. This is R perpendicular into N2. So that should be 0. No other torques. So that means if I take L by 2 N1 plus x N1 minus L by 2 N2 plus x N2 equal to 0. So that will give me L by 2 common N1 minus N2 plus x common N1 plus N2 equal to 0. Fine. So see, N1 plus N2 we know is mg. In N1 minus N2 we have already found in terms of force, and x is sitting here. So it is a very nice thing because you know that you have to somehow relate the force which brings it back to the displacement. Once you do that, then you have the hope to find the angular frequency. So this equation with the help of, so third equation with the help of first and second will become what? N by 2, N1 minus N2 I can write here as, okay, this is N1 minus N2, this is N2 minus N1, so this will be minus F by V, right? N2 minus N1 will be F by V, this is N1 minus N2, so minus F by V, plus x, N1 plus N2 is how much? Mg, equal to 0. So these are all magnitudes, so it will be x mg will be equal to L by 2 mu into F. So F will be 2 mu mg by L x. So we have found the force in terms of x. So acceleration will be what now? Force divided by mass. So 2 mu g by L x. A minus sign has not come automatically because we are dealing with magnitudes. But we know direction wise, if I put vector here for example, I must put a minus because displacement of the plank was given towards the right, but the net force is towards the left. Okay, so from here we know this is your square of angular frequency. So omega will be root of 2 mu g by L, and time period will be 2 pi divided by omega, so root over L by 2 mu g. So again a wonderful question from the book Irodov. Thank you.